Good morning. Welcome to Building Down Under. I'm joined today by Ken Longshaw. He's been in the industry for more than 40 years, definitely a legend in the industry, but I can't do him justice. So I'm going to introduce you to Ken and let Ken tell you about who he is, where he comes from, and what he does. Off to you, Ken.
Oh, thank you, Simon. That's a really hard thing to live up to. I don't know about legend at all, but I've been around and been in a lot of places, seen some interesting stuff, done some interesting stuff. So, and I guess my start occurred in 1977, where I was worked for an architect in Europe, and we were designing houses that basically had 100-year plus lifespans, and going in and extending, renovating those sort of houses. So I grew up with a very different take on what a house is, what it needs to be. Landed up in the north of Scotland, again designing wall frames and roof design for stuff that went right out to the Outer Hebrides and up into Skye and North Scotland. And so conditions very different, and again longevity and economy were really part of it. And then 81 I came to Australia, and I fell in love with the actual physical work of it.
Yeah, right.
So I got on the tools.
Become a tradie.
I did. 84 I got my tradie license, and look, it's been a party since. So really enjoyed it. Done a lot of different things.
Yeah, awesome. And what are you currently doing now? Where are you positioned now?
So
You're not on the tools anymore?
The team doesn't like me being on the tools, but I love it. So
Yeah. Do you find you get in the way a bit?
I do.
Yeah. That's where I find them at too. Yeah. It's they're like, all right, thanks for coming. Can you F off now?
Go back to the house. Go back to the office.
Go back to the office for sure.
Now, look, we're in the Southern Highlands, so it's climate zone sort of 7. It's not alpine, but it's subalpine. So right now it was about 5 degrees when I left, which is warm for this time of year.
Yeah.
And but in the summer we get a couple of days where it's 35, 40 degrees. So it's a lovely place to live, and a lot of people have escaped from Sydney, moved down there during COVID.
Yeah, during COVID, I saw a massive shift from Sydney, especially because people could work from home. When they're working from home, they were like, well, we might as well live in a really nice area. So Southern Highlands got smashed with Sydney-siders.
Yeah, pushed the price of property way through the roof. That was one of the downsides of it. But we get 4 seasons. So we've just gone through autumn, and all the leaves fell, and they were beautiful, bright reds. So it's good.
Yeah. It's a great part of the world.
Not bad.
Yeah, it's God's country, right?
I don't want to talk it up too much.
Because otherwise everyone moves down there.
Absolutely.
It won't be God's country anymore. It'll become a city. All right, awesome. So I've brought you on today to specifically talk about passive housing. I'm happy for the conversation to go anywhere that you like, but you are one of the guys that I know that know a lot about passive housing and the science behind it. So I'm happy to be guided by you, and I'll ask questions if that's all right. If we go along and I'm a bit confused, I might just ask. So yeah, head into it.
It's a big subject. It's really, really easy to get confused in. Passive housing is a very broad area. There is a very specific methodology that was developed in Germany starting in the late 80s and sort of formalized in the early 90s, called Passivhaus. So it's Passivhaus. And it is a scientific protocol to formulate a living space that has certain parameters around it. But to step backwards a little bit, particularly for us tradies, and possibly even people thinking about using Passivhaus, it really is all about comfort. So to understand what comfort is as it relates to living in a house, being a human, been quite a bit of science about what does it take to be comfortable as a human, and what you would see as comfortable is different to to the next person. My wife likes the room at 14 degrees. I like it at 18.
Sure.
So even across, 2 people in the same room, there's a very different idea. But generally, comfort in a house can come down to a couple of specific parameters. The first one is temperature,
Yes.
and the second one is humidity, or relative humidity. And both of those affect directly how comfortable a human feels. So humidity is very vital mixed in with temperature, because your skin can feel warm at a cooler temperature if there's a higher humidity, because you're not perspiring, and that very fine micro moisture coming off your skin makes you feel cold. So there is a range. In the Greater Sydney area, the average relative humidity is about 57%, and the human is most comfortable between 30 and 60% relative humidity. So if we can achieve a house, a living space that has that right temperature and right relative humidity, a person feels comfortable in that space. And that's what really the scientists who developed Passivhaus were focusing on. So there's a couple of principles around it. In the 1780s, there was a scientist who realized that when gas got warmer, it got bigger, and so it moved.
Right.
That translates into building as if you have a surface that's, say, 17 degrees, and you have another surface that's 20 degrees, the air won't move between them. The heat won't translate.
Right.
1 degree different, and the air starts moving. So it's taking energy from the higher one and moving it to the lower temperature. And so you now start to get air movement. So if you can keep all the bits and pieces inside a home, the furniture, the floor, the ceiling, the walls, within 3 degrees of each other, you're not going to get this breezes and things moving around in a house.
Right.
Secondly, if you can keep the relative humidity inside the house between 30 and 60 degrees, the people moving through it are going to feel comfortable. So Passivhaus set out to create spaces that have those principles. Yeah. And there are 5 major ways that it does it.
Perfect.
Obviously, the first would be insulating it. So they call it super insulation.
Which is different to standard insulation that we would see in a conventional build, where we put wool bats in the walls. The insulation is a bit different, or is it similar?
It is virtually the same, Simon. It's just how you do it and what you do with it. So whereas we might put R2.5 in a 90 millimeter frame, in a Passivhaus you're probably starting at 140 millimeters with an R3.
Right.
Okay, so super insulation, they're going up to R7 in the ceilings.
Yep.
So, and again, every single location, so your specific block that you're building on will have a different to one 3 streets away, a different design, or slightly different design, a modified design.
Yeah.
So as of a few years ago in New South Wales, we have to build to 7-star. That's about insulation and water usage. So
this would be the 7-star Nathers
Yes.
or Basics,
Basics,
in some areas, yeah.
So that regulates how much energy a house consumes.
For sure.
So the insulation means that every dollar you spend heating your house, it kind of stays inside the house.
Yeah.
Whereas if you take a current house built in the 80s, if you spent $20 heating the house inside, you just watch the $10 notes floating through the glass.
Yeah.
The old 6 mil glass or 4 mil glass.
Yeah, or even smaller, 3.6 mil glass. Yeah.
Or going around the outside edge of the glass and out through the
Yeah,
glass.
through the ground.
And so I think Alan Bond said 12-meter yacht racing was standing in a cold shower tearing up $100 bills.
Yeah, okay.
Trying to heat a 1980s house,
Yeah.
it's almost as bad.
Yeah, gotcha. So
that's
first component is insulation for a Passivhaus.
really high insulation. Starts on the floor. So your slab or your underfloor needs to be properly insulated. So it goes back to the design, and you've got to begin with that in mind.
Yeah.
and then it's got to be wrapped. That's well above the standard 7-star standard.
Right.
The second area where heat and energy and dollar bills leak out of the house is through a thing called thermal bridging. So if you went outside on a cold day and felt your aluminium windows, they're going to be warmer than, say, the grass or something else, because the heat energy inside is transferring through the aluminium, through the glass.
Yeah, that makes sense, right?
Makes sense, yeah. So there's been a lot of technology in making thermally bridged window frames. Of course, timber is the ultimate thermal bridge,
Right.
but that requires a huge amount of maintenance, and timber's really expensive because it's a finite resource. So looking at not just the windows, but say you've got cladding on a house,
Yep.
or even bricks on a house. So a passive house can be anything. It's just how you treat the thermal bridge. So you don't want warmth from inside transferring to outside.
Right.
The next thing is...
So, sorry, Ken, to cut you off. Does it work the other way as well? Like, are we stopping cold from getting out? So in summer months, are we also trying to stop the cold from getting out and heating up the house? Or are we trying to stop, in summer months, the heat getting in? Does the bridge work two ways, or is it just one way?
No, 100%, you're exactly right. It works both ways. So in summer, you don't want, sort of 40-degree day, and you've got your air conditioning set to 20 degrees. You don't want that 40 degrees coming inside.
That's right, yeah.
Or putting that energy back into the house. So that's how E-glass or low E-glass works. It stops that thermal transference of the energy from the sun going through the glass and bringing energy into your house to warm your house up. That you now have to buy electricity to take the heat out of the house.
To take the heat out, like air conditioning,
Exactly.
as people know it, yeah.
Yeah. So, the thermal, again, it comes back to that 3-degree difference. If you can keep everything within that envelope,
Mm-hmm.
you're not going to lose energy, because as the air moves, it takes energy from A to B. And if you're taking energy across your building, the outside of your wall to the outside, you're cooling the outside or heating the outside air, which
Gotcha.
you don't want to do.
Okay, so point 2 was thermal break.
Yeah, thermal bridging.
Thermal bridging,
So
sorry.
you've got to make sure, you put a thermal break in it, so
Yeah.
you're correct.
Okay, no, well, I'm still learning, Ken, so, but
Aren't we all?
yeah, so the third step of
Third step is then, okay, so you've now got no physical heat energy being transferred. You now want to stop the air moving
inside the building.
from inside to outside.
Okay, gotcha.
Okay, so air tightness. So think of a plastic bag. If you can get the house so that it's airtight, then you can control how the air moves in and out. So it's not about wrapping yourself in a plastic bag. It's about stopping the energy you've spent, the air you've spent money warming from getting outside. And I don't know if you've ever been into an old sort of Victorian era home and stood near the skirting boards, and your ankles get cold because the skirting boards.
There's a draft, right? Yeah, there's always a draft.
There's always a draft. You stand near the windows and there's a draft because everything was leaky.
Yeah.
So air tightness is about controlling any hole where air can get out.
Right.
So pipes coming in through the walls, lights going up through the ceiling, windows, the edge of windows, the doors, everything where air can move through from outside to inside, inside to outside, you've got to control that. Right. So that obviously means a lot of detail. So there's a lot of special tapes that you tape up the corner of your roof with, that you tape the corner of the wall to slab or floor junction with.
Yeah, so these tapes they're like a flashing, right?
Exactly.
Okay.
Yeah.
But,
so you stick them on.
better than a flashing, because they're not just watertight, they're airtight.
Airtight.
Gotcha.
So there are special tapes where you bring a water pipe through or a drain pipe through. They've got to be flashed, and so where your drainage goes out through the slab, it's also got to not transport energy out. And then they test that by doing what's called a blower test. So they plug this fan on the outside of your front door, lock everything up and turn it on, and it pumps the house up to a certain pressure, and then it reads how long does it take for that pressure to drop.
Right.
So your house
How much leakage do you have in your house?
That's exactly it.
So we're filling it up with pressure and then monitoring the pressure to see how slow, like ultimately there's no leakage and it just holds pressure forever. But I assume there's always some leakage.
Yeah, look, zero point 0.6 air changes per hour is considered enough to get passive house certification.
Okay.
Right, so your average house probably has 10. Modern houses that are slightly better, say it's a 7-star, you might get down to 4 or 5. So there's a long way to go. Tremendous amount of attention to detail in the build to get the air tightness. Part of air tightness becomes 0.4, then you've got high performance windows and doors.
Right. Okay.
So what that might mean in the Greater Sydney area is double glazing. What it can mean up in the Highlands or in alpine areas, triple glazing.
Triple glazing, yeah.
And again, it depends on the block, which way it faces, how much sun it gets, how much wind it gets, and all of that's got to be modelled. So there are guys out there who are trained to do this, and they charge a bit of money to model and design the house. And so on the southern face, where you've got a lot of wind, you need triple. On the north face, you might only need double glazing.
Right.
Yeah.
And this takes into consideration things like shadowing as well, or window type, I assume?
Yeah, so...
Are you restricted on your window type? Are they just restricted to sliding windows, or can you still get awning windows? I assume like breezeways or louver windows are out. Like, do we have a variety of windows that we can still use in a passive house?
Yes, the short answer is you don't need to change too much the materials or the style of materials you use. So obviously the performance of the actual window construction itself comes into it. So the obvious choice is the UPVC windows. And they're basically a specific thickness of, for want of a better word, plastic that's wrapped around a solid steel frame.
Gotcha.
And then it's got all these operations. But the primary thing is that the windows are double sealed. So if you have a look at a UPVC window or even a good quality double glazed window, it's got double seals that when you lock them are pressed together. And so that reduces the amount of airflow.
Gotcha.
So the air tightness of your doors, so, you know, stacking doors, sliding doors, opening doors, awning windows, double hung, casement windows, hopper windows, all of that sort of stuff is totally agreeable as long as it has the right air seals on it.
Right. So when it seals, like I think back to my house, I've got a sliding door, and that draft, I can still feel it coming through where the fixed panel and the sliding panel join. So that clearly doesn't have a double seal.
No, that's mostly got a felt schlegel or a bit of strip of felt,
Right.
And it will stop dust, breeze,
A little bit of dust. I find our house is always dusty. Thank God for Magda always cleaning.
I think that's modern life today, Simon. It's just, it's dusty.
So in a passive house, like not to get off the 5 points, but in a passive house, we're reducing dust as well then?
Yes,
by default,
very much so, very much so. That sort of leans into definition of comfort. So people who have allergies or asthma find passive house incredibly easy to live in.
Right.
For 3 reasons. One, the relative humidity is controlled.
Yeah.
So you set what relative humidity you want. So an asthmatic will find a dry house really problematic. Whereas if you get that 30 to 60% relative humidity, they find it a lot easier to live in. Anybody with allergies will find a passive house very easy to live in, because the 5th point that we could jump onto is the mechanical ventilation with heat recovery. So MVHR.
Yeah.
Mechanical ventilation.
Explain this to me, Ken, because it sounds a lot fancier than what I'm used to. So MVHR.
When you build a house, Simon, what's your average spend on air conditioning system?
So average 2-story house, probably $20,000.
Right. So an MVHR system for that could be a quarter that,
Right.
because it's not heating and cooling, it's merely moving air from inside the house through a system of heat exchange to outside and bringing humid air from outside
Yep.
in, exchanging the heat and putting fresh air inside your house.
Gotcha. Yeah.
So mechanical ventilation, heat recovery, and it's set to be the right number of air changes, so you're not getting stuffy air, you're not getting dead spots, but your air is always warm and at the right humidity.
Right. And when we say warm, it's not hot. It's just comfortable. Comfort.
You can set the temperature, and again, this would come in now. You would need a heating or slash cooling system added to the average MVHR, and then so it becomes MVHR AC. So
Right.
mechanical ventilation, heat recovery. So that's those dollar bills that are flying out the chimney. It's catching them and bringing them back into the house.
Okay, gotcha. So it's recycling the temperature from inside the house back into inside the house.
Yeah.
So similar to when you're in the car, you can turn that setting of your air conditioning into recirculation.
Absolutely.
So a passive house is recirculating the air, no loss going through the barrier that we've created.
Minimal loss. Yeah.
Okay.
I mean, look, they discovered, just for a quick digress,
Yep.
Penguins, they can walk around on the snow.
Sure.
Okay.
Yeah, they have cold feet, right?
They have cold feet.
Yeah.
So do,
Polar bears. Yeah. Yeah.
Most water birds have their cold feet. But there's actually blood going to their feet.
Yeah.
And what they found is there's a mesh just above the ankles where the hot blood going in passes the cold blood coming back up and swaps its heat.
Right.
So the penguin doesn't lose any body heat through its feet, and it doesn't bring ice cold blood back into its body.
Right.
Okay, because they have that crossover. And so this is just one of those biomimicry technologies that said, hey, we can recover the heat. So
That's fascinating.
you're not taking the dollars out of your pocket and just watching them disappear. They're staying inside the house. So my next door neighbour has a classic project home.
Yeah, like from a volume builder.
From a volume builder,
Gotcha.
built in the mid-2000s.
Yeah.
Right? His energy bill is close on $1,800 a quarter.
Right.
Okay. I don't live in a passive house. I live in a straw bale house that was built with some passive house principles. Mine is probably $600 a quarter.
Right. Okay. So you're 1/3, and you're not a 7-star rated passive or certified passive house.
I ran out of money like most
Yeah.
builders. So
Okay. Yeah.
we're not quite there.
Yeah.
But I did seal up the windows and seal the roof and stuff like that. So a good passive house should achieve about a 90% saving on your energy bill.
Right. Okay. So yeah, it's good that you bring this up because there is the elephant in the room. That how does this apply to Australia? So I understand the concept that it should work in places like Germany and Poland where they get minus temperatures and they're freezing cold. So here in Australia, like, what is the benefit? But the elephant in the room is how much does it cost to do this? So how many years do I have to live in a passive house before I pay off, I assume, the extra cost during the building and construction?
Yeah, that's the $100,000 or $64,000 question.
Okay.
So let's take it in two parts. We're not Poland, we're not Russia, we're not north of Germany where this was instituted.
Yeah.
So does it have value where we are? I built straw bale houses, and I got asked to go build one up in Noosa, just outside of Noosa. And I was like, why would you want to live in a straw house in Noosa?
Yeah.
Right. So we put the walls up, went away. Somebody came, put the roof on. We went back to render the house. There were no windows in it. It was still just a big open cave, and it was midsummer. It was high humidity outside. I walked into the straw bale house, and I was like, that's why you build straw bale up in Noosa. It was 20 degrees cooler.
Right.
Okay, so massive insulation even in hot climates, without the air tightness, just changes everything. So you put a passive house in a hot climate, you get just as much benefits because you're not having to spend the money on cooling.
Right.
So in Australia, yes, there are trade-offs. So would you say you were building in the northern New South Wales, go for triple glazing? No, it's overkill. Double glazing is good because it does reduce the amount of transference of the cold that you're air conditioning to the outside. So that said, we come back to the cost. So yes, there is a little bit of extra cost in a passive house. Most of that comes to the amount of labour in detailing it. So your first cost is getting it designed.
So when you say detailing, you mean the design of, like, doing the science, working out the science behind it?
Yes. So let's just step back. There's a couple of levels of passive house. There's certified passive house, where you can actually get a proper sticker and a certificate that said your house was designed and achieved these levels, and it is now certified passive house. You can get something that is a non-certified passive house, so you don't have to pay that extra for a couple of tests and certificates, and then you get one that's built to principles of passive house. So super insulation, air tightness, double glazing, high performance windows and doors, and the way you treat and move the air around the house.
Yeah.
Without actually going to the extent. To get that design specifically for your block is like getting a NABHERS or NATHERS certification done. These guys have had special training.
Yeah.
They run special programs, software that's certified by researchers in places like Germany, where the universities are, etc., that design this, and that costs money. So initially you're up for a little bit extra in the design of your place. Where the real cost comes down to is attention to detail by your builder, by your carpenters. So the carpenters, the actual guys hammering the nails in, need to know what level of quality they have to achieve.
Right.
Most of that is around wall floor junctions, roof wall junctions, penetrations. So where your pipes go out, where your windows go out, where the air conditioning vent comes in, where the lights penetrate the ceiling. And you need to use very specific product that is like, you're not just your standard sisolation silver paper. It is moisture control barriers that are either stuck on or nailed on or screwed on. And they don't allow the pressure, the air to leave. They do allow vapor, water vapor to leave, but they don't allow moisture to come back in.
Right.
So we're all used to the moisture barriers.
Yep.
And we're getting good at that.
Like our sarkings and things like that. Yeah.
It's sarking with steroids, basically.
Okay, yeah, that's a good way to describe it, Ken.
But then mostly we just lap our sarking 100 mil. That's great. It's done. No, this one you've got to tape it up.
Tape it, yeah.
Because the air can find its way out through that.
Right. So is this cost, is it mostly in labour rather than material? Is it because the carpenters and everyone have to take that extra time? So is that the increase in price? Or is the material quite a big section of that increased price as well?
Material's a percentage of it, possibly 10. The labour is probably, once the team understands it, there's probably a 10 to 15% impost in extra time taken. Okay,
so not too much, not crazy differences, especially if we're going back to saving 90% in energy costs at the end. So we could recoup these costs really quickly then.
Yeah. Plus, you're not putting in a $30,000 to $40,000 air conditioning system. You're putting in a $6,000 to $10,000 heat recovery system.
Right.
So there are immediate sales benefits. or cost benefits.
Yeah. So would you say that a conventional build, like let's exclude project builders or volume builders because they've got a lot more better buying power than custom builders like we have. But if we exclude them and we're saying that a custom build versus a passive house custom build is not actually that different in price.
No, it's percentage points. You know, sort of if it's something that the team already knows, you're probably up to 10, 12%. If it's something that you don't do every single day, it's maybe 15%. Because it's normal principles, it's just a little bit more attention to detail.
Gotcha. So because of this increase in price, the cost, I assume a lot of clients go, oh, hang on, 15% extra. I can save 15% right now. So how do you respond to clients that, what gets them across the line?
That really is a good question, Simon, because when we think of building now or buying a house now, we've been so trained to look at, what color are the tiles, what, is the kitchen polyurethane, how much landscaping and driveway do I get, and what's the number, what's the dollar, what's the bottom value?
Yeah, or everyone's always looking at cost, right?
Absolutely.
So, yeah.
As opposed to, how much will this house cost me for the next 30 years?
Right.
So, I go back to my background. Originally, I was working on houses that were built to last over 100 years, and we were working on 300-year-old houses. Now, when you build a fabric that's going to last 300 years, you spend a bit more time in it. Whereas most Australian homes don't last more than 30 years before they're entirely bulldozed or very largely refurbished. So the value we put on a home is very different to what it was up until the 1950s when the gang nail was invented.
Right.
It allowed roof trusses and wall frames to be built. So what I ask customers is, what's your living experience going to be in this house?
Yeah.
Right. We spend a lot of time looking at the view, looking at how you're going to get the garden, where's the sun coming from, what do the bedrooms look like. But after you've spent your money, how does it feel to live in this house? Are you going to need to walk around with jumpers on and slippers because the slab's cold and there's lots of breezes in the house? Or are you going to be really comfortable in this house and not be paying huge energy bills? And that is shaping up to be a horrible thing, cost of energy.
Yeah, absolutely.
It's gone crazy. So it is a balance, and if you are going to the level of certification, part of the design and the certification will show you what your expected savings will be across the next 30 to 50 years. So if you're saving 50% on energy bills, which is really conservative, a lot of people save up to 90% on energy bills.
Yeah.
There's a lot of lower cost of actually living in this place. And for someone who's possibly looking at a future on a fixed income to retire, that starts to really count. So in the early days of Passivhaus, a group of social housing builders brought the concept into some social housing in Bath in the United Kingdom.
Mm-hmm.
And what they found was people on social security were spending 75 to 85% of their social security income on heating and cooling and just the utilities.
Right.
So they built a whole set of social housing using Passivhaus principles, and that dropped to where they were spending 10 to 15% on their thing. The economy benefited in the immediate locals, the microeconomy benefited because suddenly you got this whole group of people who've got extra cash to spend.
Sure.
Down the pub.
Yeah.
Down the
going out to restaurants.
The local cafe, clothing.
Watching movies. Yeah.
The quality of life for those people improved.
Of course.
The healthcare costs dropped. So the actual benefit, the societal benefit, was immediate and apparent. The environmental benefit was also calculable. because there was an immediate drop in the amount of electricity that was demanded for air conditioning and heating.
Yeah, for climate control.
Climate control. And the houses lasted longer. So add into the mix of the cost benefit analysis is how long the actual house will last. If you've not got moisture damaging the fabric of the home, the structure of the home, your house lasts longer.
For sure. And the moisture we're talking about is the moisture inside the house, like moisture in the air attacking the house from the inside. All right. So do you would say that our industry at the moment focuses too much on the cost of construction at the beginning and not looking at the long-term value of the property itself? Are we building disposable homes at the moment conventionally?
Don't get me on that huggy horse, Simon.
Okay.
Yeah. Something
I poked the bear here.
very passionate about. Look, I talked with a builder up in the north of England, and he was telling me they built this house, and the owner came to visit, and he goes, "What are those?" He goes, "Oh, those are oak trees." I goes, "What do you mean?" He goes, "Well, in 100 years' time, this place is going to need some maintenance, and so they'll be ready, and then in 300 years, it's going to need some major maintenance, so they'll be harvestable by then." And the guy was blown away, and he goes, "No, that's just how we build."
Yeah, right.
Okay, now, to me, that's what a builder is.
Yeah.
You know, you don't just think about now; you think about the next
100 years.
You know,
Right? 200 years.
Yeah. It would be lovely to think about 300 years. You know.
Yeah, well, I've traveled through Europe, and we're looking at buildings that are hundreds of years old, like churches. Sure, they've got maintenance, and I'm sure there's maintenance in passive homes, but these are buildings that last the test of time. Here in Australia, you're right, we're a really young country, but we've already got homes that it's not worth maintaining anymore. Might as well knock down, rebuild it. So it does appear that we're creating disposable homes like everything else, like everything we're buying off certain websites that are just cheap, easy, quick, but they don't last the test of time.
Yeah, one use fashion, one use house. So, I drive down the street and you look at, there's a couch sitting on for curbside pickup, and I think somebody did a lot of research. They visited a whole bunch of furniture stores, they sat on a bunch of couches and they chose that fabric, and now it's out on the sidewalk. We are in a disposable society.
Yes.
So the idea of building a house that lasts is something that not everybody will understand. And not everyone will see the value of. But if it hits your hip pocket immediately in the cost of living, so it's the difference between a retired couple being able to go out for coffee twice a week and go to a restaurant once every week, as opposed to not, because there's just not enough funds there in their superannuation to benefit that. So there is a real calculable benefit. And going back to the initial design, the guy who actually does the numbers, the scientific numbers about your passive house, he will tell you what your average savings should be across time.
Right.
So as a builder, we can sit down in front of the client and go, okay, you've asked for this, these are the costs, and here are your savings. So just on savings, you could save the extra cost across the next 15, 20 years. Now, that may seem like a long time, but it is there.
So because it's going to take 15, 20 years to see these savings or really enjoy the benefit of these savings, if someone's planning on living there for 10 years, they're building a house, planning on living there for 10 years and thinking, oh, it's not our dream home yet. So they're probably unlikely to want to go for it. But is there a benefit in itself having a passive home where is the value of the property worth more? Because
100%.
Okay.
Yeah. So you can charge a premium for your house because the incoming owner knows that they've got a really high quality house. There's going to be no maintenance issues with moisture destruction. We just swapped out every single window in a beautiful old cottage in Bowral where all the old windows had leaked and 20% of the frame needed replacing. And, so here's a cost on an 80-year-old home. Yep. And so
ignoring the cost of the thermal control for the last 80 years, but then there's another maintenance cost that you've thrown in there as well.
So if you go the full Passive House certification, you've got an extra piece of equity that is worth money when you put it in the sale for sale.
For resale value.
So you will recoup that money a lot quicker than 15 years.
Right. If you decided to sell. If it's your forever home, then yeah, you're going to be in there for 30, 40 years anyway.
And your kids are going to want to come live with you too.
Yeah. And so even like if we stick on that resale value, when people walk in the home, do they feel the difference straight away? Like on a hot day, hot Saturday, open homes on, the doors are open, and someone walks in, do they feel that difference between, is there an acoustic? Is there like, where do the buyers now feel the difference before they go and spend that extra money on the value?
That's a hard question because there is no way of telling if it's a passive house other than being told. Right. So there's not a design that you look at and go, oh, that's a passive house. So up where I am, there's one that's, it's the typical no eaves, colorbond sheeted with standing seam house. Gotcha. And then there's another very typical cottage with, lovely 30-degree pitched roof and eaves and colonial bar windows. It's also a passive house. So you can't just tell. You
can't visually see it.
No.
Similar to you can't visually see a double brick home versus a brick veneer home. If the inside's been plasterboarded, you can't tell. But there's obviously benefits between a double brick and a brick veneer, but you can't tell the difference unless you're told. So having the certification and the testing done would be important then for resale.
Yes. Yeah, I mean, having one that's quasi-passive house without certification, you're going to be able to talk about it, but you can't scientifically wave a piece of paper and go, there's the certification.
There's the evidence.
The door blower test said that we're at 0.55.
Yeah.
So, but you should feel, say you walked in on the hot Saturday at an open house, you should feel immediate drop in temperature as you walked in. If you walked in on a cold day outside, you're going to feel immediately warmer because the fabric of the house maintains a temperature. Your slab, your walls, your ceiling are all within a very close range, and so your body perceives the comfort immediately.
Yeah. So you just said the word fabric, and I've heard this about passive homes. It's fabric first ideology, right? Like we're starting with the fabric of the house. So I have to ask then, what if we've got a house that's not a passive house, but we want to renovate it? Can we convert it to a passive house, even though the fabric from the beginning, so we might have issues about the penetrations through the slabs and stuff, but can we get it closer to a passive house? Or if not, get it to a passive house?
Short answer is depends.
Right, okay.
You can improve any house, and you can get a very, very drastic improvement. It's the 80-20 rule. 20% of your improvements are going to take you 80% of the way, or maybe 70-30.
Yeah.
So just by upping the level of insulation, foaming around windows or swapping out windows and putting double glazed windows in and making sure they're well sealed, sealing your skirtings, little things like that, which are the 30%, can get you 70% of the way.
Right, so we won't necessarily get it to certified passive house, but we could also start getting some of those savings that a passive home has the benefit of and the values that a passive house has. We could get 70% of that. So we might start saving 50-60% on energy rather than the 90% that a full passive home can achieve.
Absolutely. So there is very low-hanging fruit, and I think you'll find most quality builders now, particularly the space we play in Simon, are using those quality build principles in that, sealing up the windows, making sure they're using good quality doors and windows that are not leaky themselves, and educating the client about the value of extra insulation. And just a really strange fact, if you have a full house and you have two unsealed downlights in your ceiling,
yeah,
you might as well not have any insulation in your roof, because the amount of warm air that'll go through those is really reducing the amount of insulation. So most of your good quality builders will have a special dome that goes over
Yeah.
your downlight.
Yeah.
And so largely...
The dome we're talking about, for clients out there, we're talking about the dome that goes in the roof. You don't see the dome. It's above the plasterboard ceiling. It's just so you can, so when electricians install downlights, they will actually cut out the insulation in that area so that the downlight itself is not touching the insulation. But then Ken's saying that's where you've got a leakage. So these are the domes we're talking about. Sorry, Ken.
No, that's a really good explanation. And then those domes themselves can have insulation put over the top, and so you can achieve an R6 insulation in the ceiling with a standard house. So you can take a 1980s or a 90s home, and you can bring it 70-80% of the way.
Yep.
With things like good insulation, good windows. The floor is a difficult thing. If it's a concrete floor, a lot of heat does dissipate out into the ground, so you wouldn't achieve much on your concrete floor, but you could put a level of something on top, which then insulated over the top of the concrete slab.
So batten up and build up and create the insulation on top of the slab.
Yes.
Yeah.
So the passive house principles, while the passive house organisation and people don't like that term, the fact is that good insulation, airtightness, and the quality
of build
of the build,
yeah,
you should get that off most builders. And certainly the government, by pushing 7-star, is trying to take us in that direction. So a bit of carrot and stick.
For sure. I want to ask about a myth that sort of happens, and with a passive home, because we're controlling the air inside, does that mean we can never open a window? Otherwise we break that seal?
Look, that was something I was under the misapprehension of as well, Simon. The fact is no. Opening your windows, all your windows are just standard windows, and you can treat it like a standard house. If you want to just turn the power on the motor to your HR heat recovery system off, and then when you close the windows, turn it back on again.
Right.
So getting that fresh air. But the fact is that you're getting the right amount of fresh air brought into the house. So the calculation done is that you've got so many cubic meters of air in this house. We need to change that out so many times an hour for it to be healthy, for it to be comfortable, and for it to be economic. And so the health and the comfort are your top priorities, not the economics. So an asthmatic might find that they never want to open the window because the fresh air that's coming into the house has been filtered and is warm.
So it's almost like you wouldn't have a desire to open the window. It's not that you can't open the window, you could, but you wouldn't actually desire it, because living in the home, you're just comfortable without that fresh air because you're actually getting the fresh air through the system, right?
Yeah, the system is providing continual fresh air. I mean, Simon, it's a bit like having a fire. It's good for your soul, but you don't really need it, So
yeah,
you might psychologically want to open the windows, just so you hear bird song or traffic, something like that. But the white noise coming in from outside, because one of the things about double glazing and the amount of insulation is going to be a very quiet house to live in.
Right. So, okay. So acoustics as well. Yeah. So you might miss the magpies singing to you in the morning. You'll have to open a window if you want to hear that.
Definitely.
So I guess, like, coming from the blind side of not understanding fully a passive home, obviously because I'm not a certified builder for Passive House, but I imagine it would be stuffy in there. But from what you're saying, it's not stuffy at all. That, even though it's all locked up and closed off, it's this system at the end that recirculates the air, that filters it again and avoids the stuffiness. Am I understanding it correctly?
100%, Simon. The whole principle behind Passive House was comfort. That's the baseline. So achieving a living space that caters to the human level of comfort. So that temperature range, 18 to 22 degrees, the relative humidity range of 30 to 60%. that is the whole principle behind it. And the fresh air, the filtered air. So if you think about places like Europe, where there used to be a lot of diesel smoke and pollution and stuff like that, those filters were quite vital. And so the benefits of it become, you immediately feel when you walk into the house like that.
Yeah, awesome. And because of this filter, how does a passive house help, like in events like bushfire? So you're just mentioning in Europe, the diesel smoke and stuff like that. Here in Australia, I guess we have bushfire smoke. So is there any benefits, like with the sealed house and having it filtered? Does this stop the smoke getting in?
Absolutely.
Yeah.
It's just a really good quality filter. And, as long as you watch the news and have a good smoke alarm, you won't get caught in a fire because you won't smell it.
Right, gotcha. Okay.
So it's filtered those out. Obviously, there is a level of maintenance on a filter like that. And so there are protocols around maintaining, any air conditioning system needs itself maintained.
Yep.
So just like you change your water filters, you need to change the filters. But it's certainly no more costly than any of the other systems that we put in our houses.
Right. So now that you brought up maintenance, as a whole in the house, so obviously the air filter will need to be maintained, and there's X amount of years between changing the filter or cleaning the filter or what you need to do. What other maintenance do you save by building a passive house? Like, do you save on having to maintain and paint the exterior or the windows, or is there any other savings with the maintenance over the next 100 years because we're building a 100-year home?
Yeah, a passive house is exactly the same as far as the materials you use to clad your house, your windows, your floors, paint on the walls, as any other house. The only maintenance you won't be doing is degradation through mold and degradation through moisture. So I was in a house last week where there were just literally rivers of water running down the walls.
On the inside?
On the inside, okay?
Yeah.
And, there's reasons why old houses can do that. So you're never going to get that sort of degradation. But, you could use cladding, you can use brick, you could use colour bond on the outside of the house. And so if you want a zero maintenance, I built one up in the Highlands where we put standing seam, colour bond. It was a matte. It's beautiful, and it's never going to need to be maintained. So that comes down to, as a builder, and what does your client want? You may not want to pay for standing seam, colour bond, but you may want to go for, something else. So know that you can use any material, and the maintenance will come down to the material used. The benefit is you're not going to get moisture degradation inside the house.
So it's almost less maintenance cost over the lifetime of the house, and you're getting the house to live longer.
Yes, you can definitely look at it like that.
All right. Okay.
I mean, my kids run around with grubby hands all over the walls, so passive house or not, I've got to paint the inside.
So where do you think passive house is going to end up in the future for Australia? Is it something that's picking up and getting traction, or is it, I guess with interest rates and that, is it getting sort of shut down, or where's the future of passive house builders?
7-star is a milestone along the road to better quality living. Passive house is kind of the end point. So I think the principles behind which passive house was created have been adopted by the government into the next changes we'll see in the National Construction Code. They're certainly being pushed by the academics because they can all see the benefits of it. How quickly it gets adopted will come down to any number of factors. I think generally clients see the benefit of it. It depends what's happening on a macroeconomic level and a microeconomic level as to the decision made on the day. But starting with the concept of those 5 concepts, when you start to build, think of those 5 concepts and incorporate them, you're 70% of the way there. So you may not want to actually spend the money to go 100%, but you can get a long way towards having a lot better quality of life inside your house and having your house last a lot longer by thinking the same way.
Right. And do you think in the Australian building industry, there's still a misunderstanding of passive housing? Like, it's complicated, it's too expensive. Is this what's holding us back, and we're just slowly getting to the 7-star neighbours and stuff like that?
The Australian Passivhaus Association is doing a lot of work at an education level, educating government, educating designers, educating architects and people as to exactly what it means. There are courses, they run courses for tradesmen, for designers, and I think we're going to see the benefit of it slowly increase. So it's very early on in the journey. The actual passive house was only formalised in the mid to late 90s. So
Here in Australia?
No, in Europe.
Oh, right, gotcha.
Yeah, and so there's a long way to go along the road to getting there, but the benefits are very easy to see, and I think they're pushing us to get off gas and get onto electricity now. The cost of electricity is going up. The whole energy environment has been put into doubt as to its, one, the sustainability from an economic point of view, and secondly, its reliability from a global geopolitical point of view. So things that can reduce your reliance on external source. So if you take your energy needs from a house and drop it by 90%, means you need a much smaller battery on your solar.
Yeah.
And so you can get almost completely off grid with a house that is a lot more energy efficient. So there's definite benefits that are only going to increase. And so the attractiveness of this style of house, as people get more aware of it and it hits their hip pocket, are going to increase.
Awesome. Yeah, that's awesome. So just for all the builders that are watching, what sort of extra training or licensing do you need to become a passive house builder?
To become an official passive house builder, jump on the, just Google passive house training. I think it was about, last time I looked, it was about $2,000. It was a 3-month course.
Mm-hmm.
There were a number of live events, as in live Zoom events or online events. There's a lot of math behind it, because it is a scientific, principled methodology. I've been to a number of training events where the actual techniques are shown, and so there was one held by ProClimber up in Sydney at the Future Build Expo last weekend. There were a number of people showing product that is definitely part of the passive house suite.
Right. Yeah, awesome. So quite easy to a builder that is like a custom builder like myself, quite an easy process to get across. And is there a different membership? So like we're members of MBA, Master Builders Association. Is there a group that you become a member of for Passive House?
There is the Australian Passive House Association,
Mm-hmm.
Passive House Association Australia, never remember which.
Yeah.
It's not expensive. I think membership's about $600 a year.
Yeah.
And
they support you and update you on things when there's changes, and
there's continual news events on my news feed, comes through quite regularly, and they're an active group, but it's at the ground level. We're really at ground, at the starting point.
Yeah.
So a lot of their push is educating into the large shakers and movers. So your academia, your political, so it's at that very high level at the moment. But at the same time, they're building a grassroots group who can service a demand as it grows. So it's one of the things I hold out to my team, that if you want to, we'll support you to go and get Passivhaus certified tradesman status.
Awesome. So not just builders, but tradesmen can also get Passivhaus certified.
Yeah, so there's two levels. There's the designer, Passivhaus designer, and then there's the Passivhaus tradesman.
Yeah.
So as a builder, we kind of sit in the middle.
We're somewhere in between, yeah.
Yeah,
Okay.
the tradesman's actually how do you stick the tapes down, and the tapes are different. They're not like duct tape where you just push it down. This is a pressure activated tape.
Right.
So you put it in place and it's slightly tacky, and then you've got a card which you rub along, and you've got to rub it a certain number of times so it fully adheres to the wall floor joint. And there's the suppliers do the technical training, but there is knowing, what's involved and how to achieve that. So it's just like anything, it's experience, and the training gives you that experience.
Awesome. And if our listeners were to take away like one main thing, what would you want it to be from this conversation we've had today?
Passivhaus is about the long-term comfort of a house from the person who's living in it, not from the hip pocket.
Wonderful. Okay. So it's comfort. I feel like this whole conversation, every 2 minutes, it's comfort, 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 and living comfortable is probably one of the most important things, not like, and then the benefit of the cost saving with the energy efficiency.
Yeah, as our population ages and heads towards retirement, obviously you become a fixed income person.
Yeah.
And so we're all going to get there at some stage. Having a house that costs you 90% less to live in is a really good proposition.
Yeah, absolutely. Absolutely. Well, Ken, is there anything else that I've missed? I know we've had a long conversation here, but is there anything I potentially have missed, haven't asked you about? I feel like we've covered a lot, but there could be something I'm completely missing.
I think at a very high level, from a macroeconomic sort of national perspective, Passivhaus or the principles behind it make sense, because it's going to reduce the impact of new housing on the energy grid, reduce the demand for renewables, and enable people to possibly be self-sufficient with a moderate battery system and solar system. So it has definite value. There is a regulatory tailwind that will come in. The myths about it are not founded in fact, and the reality is that any house can achieve very close to that level of energy efficiency without a huge amount of effort. So something as builders we should educate ourselves about. If the incoming group of tradespeople, the apprentices we have on site right now, if we can push them to thinking about the courses, maybe even sort of fund their courses, we're going to build a much more resilient industry, as well as a much more resilient business right now.
Right. So we should be pushing our future builders to understanding that this should become a standard, not a niche. Passive house builders are not a niche market. It should become the standard. And as an Aussie myself, I feel like we do want quality homes. And I remember being in Europe and seeing that they build different to what we do. We have gaps under our front doors where cockroaches and mice just come on in, and we just go, oh yeah, that's just part of living in Australia. But maybe we should set ourselves to a higher standard.
Yeah, and taking our customers with us and helping them see the benefit of it. Obviously, there is a strong headwind in the marketing of the bulk builders who have a commodity that they pitch at a price.
Yep.
This comes with a definite cost. So if you're wanting to compare, a $2,500 a square metre XYZ project home. With a passive house, yes, it's going to be a lot more expensive. If you're looking at a quality home, it's not much more expensive.
Gotcha. Yeah. So, like in the industry we work in, it's only a slight cost increase at the construction at the construction stage, but then the savings start from the moment they get OC and move in.
Yeah, yeah. And the thinking about it starts when you start thinking about the house and choosing the block.
It starts at the design
It
stage.
has to. One of the things we talk to clients about is get your builder involved early.
Yes.
Because some of the very early decisions taken can affect the cost dramatically. And so if you have a builder, particularly, if you're thinking about going passive house-esque, have a builder who understands that, then the early decisions taken are going to reduce that ultimate cost as you get down to the end.
Yeah, awesome. Well, Ken, thank you so much for coming in. I've learnt a lot today. I know our viewers have learnt a lot as well. There's a lot to take in. I'm sure there's so much more about passive homes that we didn't get to touch on today, but yeah, I'm grateful that you came in and helped us, informed us, educated us, so we can be better.
Yeah, it's been a pleasure, Simon, and thank you for the opportunity. I am passionate about the environment and our impact on it, and this is definitely one of the pathways where we can reduce our impact on our planet.
Yeah, absolutely. Absolutely. Well, that's a wrap for us today. Again, I thank Ken for coming in. Ken Longshaw from Longshaw Constructions. Shout out for him. And as always, keep building dreams.